This is CS1101, lecture 10.3. We're going to be talking about oversizing arrays and using arrays of objects. Let's start with a comprehension check on what we have gone over thus far. So we have a main function and an array of integers called A is declared. Then we have an array variable called B, which is assigned A. And then we're calling the method getArray and storing what is returned in B. And getArray returns an integer array reference. Then we print the contents of A and the contents of B. Which of these four is going to be what is printed by these statements? If you need more time, pause the video. To answer this question, notice that A is assigned a new array object and initialized with these values. B is then assigned the reference to the array object already stored in A. So at this point, B and A both contain a reference to this object in this line of code. Then, when we call getArray, which has no parameters, we build a new array object, store the reference to that array object in this variable C, and then return that reference and store it in B. So A still points to the initial object, but now C pointed to a new object, and that new object's reference is stored in B. So A and B point to different objects. So when we print this out and we convert these arrays to strings, A contains 1, 2, 3. However, B contains 3, 2, 1. So just a quick reminder on some of the useful methods you'll find in the arrays class built into the Java util package. ToString is a way to convert the contents of an array to a string for easy printing. Equals checks to see if two arrays contain the same elements in the same order. Fill populates every element of an array with whatever value is passed. Sort is going to change the ordering of the elements in this array so that they are in ascending order. It doesn't return a new array, it actually changes the array object passed to sort. The same thing is true of fill. It also changes the array object rather than returning a new array object. And then we have binary search, which will search this array for the value passed. It will return the index of the location of that value in the array if it exists, or return a value less than 0 if not found. Notice that it expects the array to be sorted. So before passing an array to binary search, it would be best to sort the array, then pass it to the binary search to get the location of whatever value for which you were searching. Here are some methods that are built into the string class that actually return arrays. So the toChar array is going to separate each of the individual characters in a string into an array. So if we had the string long book stored in S, and we did s.toChar array, this method is going to return an array of chars such as this, long space book. So that's a useful method to convert a string to a char array. The method split, supplied with a delimiter, will split a string at each of the locations where the delimiter exists in a string. So as an example, if we called s.split, so remember s contains the string long book, and we called s.split, and as parameter to this split method we passed a space as the delimiter, then at each location in this string where a space occurs, it will split the string. So there's a space between long and book, so it will separate long and return that as the first element of the string, and the second of the first element of this string array, and the second element of this string array is book. But if we continued it and it was long book Tuesday, so long space book space Tuesday, then when we called s.split space, it would return the string array long followed by book comma Tuesday. So the split method will literally split a string at the occurrence of each of these delimiters. So if you pass space as the delimiter, every time it encounters a space, it will break the string in that location. And it returns the fully broken apart string, the fully split string, in an array of strings. So as another example, if we were to use O as the delimiter, so s.split, and then we pass O as the delimiter, then it will return L ng space B, right, because it split it on the O. So we have an L, then we split on the O, so the first string in our array is an L. Then we have ng space B, then we encounter an O, so there's a split. So we have finished our second string. Then immediately we have another O. So that means we are split again. So the contents of the string that we have now created between these two delimiters is empty. And then we have a K. So what a delimiter does is it spaces apart whatever we're looking at. So if we use the O as the delimiter, what we're doing is we're putting a separation in each of these locations. So then we have a string from here to here, from here to here, and then yes, from here to here, and then from here to here. So we have 3 occurrences of our delimiter O. That's going to split our string into 4 individual strings returned in this array. So consider this. Sometimes we know how many elements we will need to put in an array. So let's say we're building an array to contain the temperature for each day of a given week. Well, then we know for sure that we're going to need 7 elements in the array because there are going to be 7 days in a week. That's easy to predict. So in that sort of a situation, we can use a perfect size array. So when we have the ability to know precisely how many elements we will need in the array, then we are able to use a perfect size array. And a perfect size array is an array with a length which identically matches the number of items in the array. So an example of this would be if we wanted to store, like I said, daily temperatures, then we can create an array with 7 locations to store these 7 temperatures. Or we could, if we know the values in advance, we could just use the direct initialization so that our array already has the correct values even in it. But there are situations where we don't know how many elements we're going to need. We don't know how many elements are going to wind up being in the array. As an example, imagine you're building an MP3 playlist manager, and you don't know how many songs someone will want to put on a playlist. So you don't know what size of an array to build so that each element of the array is a single song. But you can impose a limitation. You could say, well, I'm going to say that you can put however many songs you want to in this array, but not more than 100. So then you could choose to use an array of size 100, and then they don't have to use all of those spaces, but they can't use more than that. So they can use up to 100 array locations to store songs in this playlist. So in this situation where we don't know the number of array elements that are going to be needed to store whatever it is we're trying to store, we would say we need to use an oversize array. That's an array that is larger than necessary to ensure that it has enough room to store everything needed. But one of the complexities to using an oversize array is that the number of elements in the array, the number of items in the array, the number of elements that are being used may not match the length of the array. So when we were dealing with an array that held daily temperatures, there were 7 elements in the array, and there were going to be 7 items in the array. But in an array used to store songs for a playlist, if I only add 50 songs to my playlist, then I'm only using the first 50 elements of this array. So the number of items in the array may not match the length of the array. For this reason, we need to handle these oversized arrays a little bit differently than we typically handle normal arrays. If you want to use an oversized array, then we're going to need to keep track of a special separate count to know how many actual items are in the array. So we could keep track of the number of songs that have been added to the playlist. That way we don't default to believing that there are 100 songs in this playlist, no matter how many the user actually adds. That way, if we need to traverse the array for some reason to say search for a song title, we don't search all 100 locations. We only search the number of locations which the user has populated. So in this case, we've put 50 songs in this playlist, so we would only traverse the first 50 songs when searching for a specific title. So when we make a method to be used with oversized arrays, these methods are going to require at least 2 parameters. The first would be the array itself, and the second would be this count. So as an example, if we had some oversized array and we wanted to pass it in to a method that would be able to print an oversized array, then we have the parameter for passing in the array, and the parameter we're going to call myArray, and then we have a parameter for the size. So this is the count of the number of items that are actually in this array. This would be a method that took the place of the arrays.toString method built into the arrays class. Keep in mind, that will print every element to a string. But if we only wanted to print the first 50 in the case of our playlist, then we would need to build our own method for that purpose. So this is a method which would take the place of the arrays.toString method built into the arrays class. The first thing we need to do to print out an array is to print a bracket to show that we are dealing with an array. So we print out the first bracket as a fence post before we begin to process the rest of the array. Then we declare a for loop which goes from 0, so the first element of the array, up to the number of elements in the array minus 1. This is the exact same logic we've used for perfectly sized arrays. Just in that situation, we would use myArray.length. Here, myArray is oversized. So we have this separate parameter called array size, which is representing the actual number of items in the array. So we will continue to print out elements of the array until index is no longer less than array size minus 1. And we increment by 1 each loop. And inside this loop, we're just printing out the element followed by a comma. Notice that this won't print out the very last element of the array, the very last element of the used portion of the array. That would be when index is equal to array size minus 1. However, we're requiring index to always be less than array size minus 1. The reason is because we're always going to print a comma after each of these elements. So for the last element of the array, we don't want to print a comma after it. Instead, we want to print a bracket. So we are going to terminate with the fence post as well. So we started with the fence post, we have our fencing, and then we terminate with the fence post in this particular instance. So then we will print out the last element of the used portion of our oversized array, followed by a bracket. So now we're going to shift and talk a little bit about objects and references and how to use arrays of objects. So remember that when we declare a variable of a class type, this variable is called a reference variable. And it's called a reference variable because we are going to store a reference to an object in this variable. And reference is the word used in Java for the address in memory of that object. So even though we've created this reference variable, we still have to make an object in memory using the new operation, like this. So this is the place where we will store our reference, and this is the object that we are going to build in memory, and we are going to store a reference to that object in that reference variable. The reference variable and the object are two separate things, but they have a relationship. The object is the thing in memory, and the reference variable is the holder for the address. It's the holder for the reference, hence the name reference variable. So this idea of reference variables extends to arrays of class types like string. So when you create an array of a class type, you're actually creating an array of reference variables. So each element of this array is going to hold a reference to some object. Just like we saw in the previous slide, we have to create the reference variable and create the object. So even though we've declared some array of a class type, we still have to build those objects in memory and then store their references in the elements of the array. So why am I making this distinction? When you construct an array of a primitive type like int or boolean, then all of the array's values are initialized to 0 in the case of int or false in the case of boolean. Now, that's not true in every programming language, but it is in Java. But when you're working with objects like strings, the elements of the array are initialized to store a special reference value which we call null. So understand, when you declare an array of type int, then all of the values are initialized to 0. But when you declare an array of type string, all of the elements contain the value null. So what is null? Null is a reference that points to nowhere. It's a reference that does not refer to any object. It's like a dead-end street. So null is not the same as 0. It's not the same as an empty string. Both of those are something, right? We can do something with 0. We can do something with an empty string. But null is different because null is actually nothing. To see the difference between an empty string and null, look at this code. We declare a string variable called S1, and we populate it with an empty string. Then we print S1 equals, and then the empty string. It's going to print nothing, right? Then we print S1 length equals, and S1 dot length. And it's going to print 0. But notice we were still able to say S1 dot length. We were able to use that method because there was an object in memory. Even though the characters stored in the string were empty, there were no characters stored in the string, there was still an object in memory. Now notice what happens if we use S2 equals null. We can print it. It'll say S2 equals null. But when we attempt to say S2 length equals S2.length, this is going to throw an exception. The reason is because there is no object here. So when we said S1 equals and then we gave it this empty string, that created an object in memory. So we were able to use these methods like S1.length because that object exists. Java can go to the address stored in S1 and use the .length method built into the object at that location. But down here, there is no object in memory. When we say S2 equals null, we are storing a reference to nothing, an empty reference. So when we try to dereference S2, when we say, hey Java, go to the address stored in S2 and use the method called .length. Java is going to say there is no object at S2. So this is a bit convoluted, but this is absolutely accurate. When you have an array of objects, an array is actually a reference to an object because an array itself is an object. So we have the array variable, the reference variable for the array, which then points to an object in memory, and each of the elements of this object is able to hold a reference to another object. So read this statement and understand it. An array of objects is a thing that points to an array of things that point to other things. Convoluted, yes, but completely accurate. So let's talk about what we can do with this idea of null and how we are allowed to use it. It's perfectly fine to store the value null in a reference variable. Remember, that's what this is. So we declare it as type string. So this is a reference variable that is uniquely able in Java to store the reference to a string object. Well, we can store the value null in it, which means there's no object here yet. And that's fine. We can store it as an initial value. If we had an array of strings, then we can store null in the reference variable in that array. We can print null. So if we have null stored in this reference variable s, we can print s and it will print out null. So that's okay. We can pass the value null to a parameter in a method. We can even return the value null from a method. And this is done a lot of times if you are searching for something and can't find it. Null is the we didn't find it here. You can test for null. So you can check to see if a value is equal to null. So if you wanted to know whether or not a particular element of an array pointed to an object or not, you could check to see if it was equal to null. And this is going to be important. We're going to talk more about that. Here's what you can't do. You can't dereference a null value. We've mentioned this previously when we were dealing with our example using s2.length. The dot operator in Java is the dereferencing operator. It says this to the left of the dot is the location of an object in memory. Go there and use this method or access this data. Well, if S2 contains the value null, as it does in this situation, Java is going to say there is nothing there. There is no object, so therefore I can't go there. This is not an address, this is an address to nowhere. So I can't dereference it and use the methods in that location that are supposedly a part of whatever object you expected to be there. If you continue on to CS1101, this is going to happen a lot because we're going to build pointers in data structures, and those pointers, when we try to dereference them, may or may not be pointing at objects. So we can wind up crashing our program at runtime because we are attempting to dereference a null pointer. Let's see if we can predict what the output of this code will be. We declare a string array called word. We create a new string array object with 5 elements. And when we have created this string array object, each of the elements is initialized to null. So we have a reference variable to a string array object, and every one of the elements in that array contains a reference. But in this particular situation, when we create it, each of those references is null, points to nowhere. So then when we print out word 0 is : word 0, this will print null. Okay, so far so good. Then when we attempt to change word 0 by making it uppercase, what's going to happen? We're saying we want the element 0 in the word array. What's stored there? Null. And we want to convert that to uppercase. Well, what we really wanted to do was we really wanted to go to the object pointed at by the reference stored in this element. But there is no reference there. There's null. Null is a reference to nowhere. So Java is going to attempt to go to this location when we tell it to dereference it, and it's going to say there's no object there, so I can't use any methods. I can't dereference it and use methods there. So it's going to throw a null pointer exception. So when we deal with elements of an array or reference variables that may be null, we have to check if they're null before we attempt to dereference them. So in this code, we're creating the string array called word with 5 elements. We are then setting word 0 to be the string hello, but understand what's actually happening. This is a reference to a string array object, and each of the elements in that array is intended to hold a reference to a string object. So we create this string object and store a reference to it in element 0 of our word array. Then we create this string object and store reference to it in element 2 of our string array. But words 1, 3, and 4 are still null. So we create a for loop to go through each element of our array, check to see if each element is null, and if it's not null, then we convert it to uppercase and store it in the element. So this will create a new string object with the same content, except all of the characters will be uppercase, and then store the reference to this new string object in element 0 and element 2. So it'll have uppercase hello and uppercase goodbye in element 0 and element 2, but it won't attempt to dereference element 1, 3, and 4. And that's good, because if it did attempt to dereference elements 1, 3, and 4, then we would have a runtime error and the program would crash. So we have a reference variable that points to an array object in memory, and then each element of this array holds a reference to a string object in memory. However, 3 of the elements contain null pointers, which means we cannot dereference them because they point to nowhere. So when you think of initializing arrays of objects, you should understand that they require a two-phase initialization. You have to create the array and then also create the object that is going to be pointed at by each element of the array. So create the array itself, and it will initially hold all nulls, then create the object that each element will point to. So in code, that would look something like this. If we wanted to initialize every element of our word array, then we could create the word array that'll hold references to strings. Then in a for loop, process each element of the array and store a reference to a string in each of those elements. So this will create a string object word 0 and store it in element 0 of the word array. Word 1, store that in element 1 of the word array, and so forth up till the third element of our array, which is the last element. So it'll look like this. We have the reference variable word, which contains the reference to the array object in memory. And this array object is a string array object, so it can only point to, each of these elements can only point to a string. But it's initially all null valued. When we first create it here, each of these elements contains a null pointer. Then in this for loop, we build this first object and store a reference to it in element 0. And then in the second iteration, we build the second object and store reference to it in element 1, and so forth. Here's a similar example where we create an array of point objects. This array is going to be called coord for coordinate. And we create a new array object of type point with 3 elements. But each of these elements is initially going to hold the value null, because point is a class type, not a primitive type. So we need to follow our two-phase initialization. We've created our array. Now we need to create our point objects. So we are going to process the entire array, so from 0 to coord.length, and at each element we are going to create a new object, a new point object, and store the reference to this object in that element. So the result will be, we have our reference variable chord, which points to our point type object, or point type array object in memory, and then each of the elements of this point type array are references to actual point objects. So when we deal with arrays of objects, what we actually have is a reference to an array of references to objects. Here's a quick conceptual question. Does this code do the same thing as the code on the previous slide? We have to follow a two-phase initialization because we want an array of point objects. So we create our array, and it's initialized to null. Then we're creating an object and storing it in this reference variable P. And then inside our for loop, we're processing each element of this chord array, and we're storing the reference stored in P into each element of the array. Is that the same? Hopefully you understand the answer to that question is null. Here's why. What this code does is, yes, we create our chord reference variable, which points to our point type array object in memory, and we created this reference variable P, which points to this object that we created in memory right here. We created a new point object, and P points to it. But then in our for loop, we took the reference stored in P and copied it into each of the elements of our array. So every element of this array points to this same object. So in the previous slide, we created 3 individual point objects, each one pointed to by separate elements of this array. In this code, we create one point object, and every element of our array points to that same object. There's nothing wrong with either of these per se. It depends on what you intended to do. If you intended to create 3 individual point objects, then this does not work. So it's important to understand what you're doing when you set about attempting to accomplish some functionality, because this is not going to generate an error immediately. It's not going to generate some runtime error or syntax error. Java is going to let you do this. You're only going to realize your mistake when you don't get the result you expected. So we'll end with a mini exercise. Pause the video, take a moment, and identify which of these uses of null is going to cause an error. So let's take them one by one and evaluate if it's okay. So first of all, we have some call to a function called a bunch of nulls, and this method expects a scanner object. But remember, what this really is a reference parameter to a scanner object. So it's expecting you to pass it a reference to a scanner. So when you call a bunch of nulls and pass null as the parameter, it stores null in the reference variable console. Is that okay? Yes, it is. So we can store the value null in a reference variable for any class type. So that's perfectly okay. Then inside at point 2, we declare a string reference variable called string1 and set it equal to null. Is that okay? Yes, just as we said, anytime we have a reference variable, regardless of what class type it is, we can store the value null in that reference variable. Null means there's no object here yet. So that's perfectly fine. Then we can check to see if string1 is equal to null. Nothing wrong with that. And actually, this is going to yield true. So then this will print string1. So it'll print out the value null. That's okay. That won't cause an error. Then we return null. Well, will that cause an error? Hard to say. We have to check the return type of this method. A bunch of nulls is going to return an integer. Well, null is a reference. It's a pointer. So it's not an integer. This is going to throw an error and say you have to return a value of type integer.